Okay, so for this FRQ, we'll do, for each part, we'll do a little bit by hand and then go as far as we can by hand, and then ultimately go to the calculator to get the final answer. So, okay, so first they give us some graph of f. So they say let f be a continuous function defined on the interval from -1 to 8, whose graph consisting of two line segments is shown above. Okay, let g and h be the functions defined by g of x equals square root of x squared minus x plus 3, and h of x equals 5 e to the x minus 9 sine x. So for part A, they say the function k is defined by k of x equals f of x times g of x. Find k prime of 0. Okay, so first off, in order to find k prime of 0, we need to find k prime of x first. So let's do that. All right, and then k is defined as two functions multiplied, so we'll do product rule for this one. Okay, so product rule is we'll take derivative of the first function. You can do it either way, but I'll start off taking derivative of the first function, and then just times that by the other function, and then do the other way around. Leave the other function, keep the first function the same, and then take the derivative of the second function. Okay, so that's k prime of x, but they want k prime of 0, so we'll just replace all these x's with zeros. This will be k prime of 0 equals f prime of 0, 0. Okay, since f is only, the only thing we know about f is from this graph, in order to evaluate these two, f prime of 0 and f of 0, we'll have to look at the graph. So f prime of 0 is the slope of f at x equals 0. So they want the slope at this point. And since this is a linear function, this part, the slope at this point is just the slope of this line. And you can see, like, if you go in between 2 points and do rise over run, you can see it rises 2 and runs 1. That's 2 over 1, and so that's the slope. Okay, so f prime of 0 is 2. Okay, and then f of 0 is just the y value at 0, which is 3. Y value is 3, so that's f of 0 is 3. Okay, and then the rest we'll do in the calculator. We could do, g prime of 0 is just square root of 3, but I'm going to do this a certain way that'll work. That'll be kind of a good way to do for other problems also. Okay, so here, let me make this a little bit bigger. Okay, so let's look at this. Oops. So I put g of x into y1, and so kind of good to do this. Let me erase this product rule. So kind of nice, and you'll see on the AP test it'll be a good thing. Just put, like, if you put a function into the calculator, like write like what that function is, and that's in the calculator. So that's y1, and then the h of x is y2. So we don't forget which one's which when we put it into the calculator. Okay, so now think about it here. We want g of 0 and g prime of 0. And so to get g of 0, we just look at, we're going to times this by y1 of 0. This will be for the calculator. Okay, and And then when we find g prime is 0, we're going to do math 8. So we'll do d dx of y1 at x equals 0. So that's what it'll look like in the calculator. Okay, so let's do that. So we'll do second mode, which is quit, to get back to a blank screen. That's anytime you want to get back to a blank screen, do second mode. And then we'll just basically be typing this in the calculator. Times. Okay, remember to get y1, do alpha trace, and then hit enter for y1, and then just do open parentheses. Okay. And that's f of 0 is 3. We found that earlier. And then we'll times that by the derivative. So we'll do math 8 to get derivative. Dx, do alpha trace and enter, gets us y1, and then just do x equals 0. Alright, and that'll be our answer there. Okay, move this. Okay, this will be 2.598. So good to get into a habit of rounding to the thousandths. So that'll be our answer. Okay, next one. They say the function m is defined by m of x equals f of x over 2 times g of x, and they want us to find f prime of 5. Okay, just like the last one, first we'll find f prime of x, or m prime of x, and then we'll plug in 5 for all the x's. Okay, so just like the last one, we'll do this, start off this one by hand. And then we'll go to the calculator. Alright, so I would rewrite m of x. You can, or at least think of it this way, as like 1/2 times f of x over g of x. Okay, that way when we take derivative, we can just kind of bring that half out and then not have to worry about that. Just take derivative of the rest. Okay, since this is a fraction, we'll do quotient rule. Okay, so in quotient rule, you always start off, our answer is going to be a fraction. So we'll always start off taking the derivative of the top, which in this case is f, and then just times that by the bottom, and then do minus the top times derivative of the bottom, that whole thing over whatever the bottom is, and that's squared. Okay, now we'll just plug in 5 for everywhere you see an x. Every one of those x's, those 5 x's, we'll just change all those to 5's. So basically just rewrite this whole thing. Oh, that should be a 1/2. Fix that. Okay, so these two f functions, f prime of 5 and just regular f of 5, we'll have to look at the graph for those. So f prime of 5. So here's 5. And so f prime of 5 will be the slope of this line that contains 5. And the slope of this line, you can see it goes down to, we'll go in between maybe these 2 points at 8 and 4. So from this point, it'll go down to and right 4. So if we just do rise over run, down to and right 3, sorry. So negative 2/3. be that slope. Okay, so f prime of 5 down here is negative 2/3. Okay, remember g is y1, because eventually, we're going to type this in the calculator. So g is y1. So if we're going to, the thing that we're going to type in the calculator, this is really, so g prime of 5 is really d dx y1 at x equals 5. Okay, then minus, so I'll go back up to the graph for f of 5. So f of 5 is just the y value at 5, which is also 5. Oh, what am I doing? I don't know where that little line came from. That should just be g of 5. Here, let me, sorry. Fix that. It's not the derivative of g, that's just regular g. Okay, so that there shouldn't be a derivative there. It's just regular. Okay, so this is really just y1 of 5. Okay, and then f of 5 we found was 5 times, and then now this is g prime of 5. So this will be the d dx y1 at x equals 5. All right, and the whole bottom is just g of 5, so y1 at 5, and that whole thing squared. All right, so we'll do that in the calculator. So let's look up here. Okay, so we still have, those same functions into y1. So now we can do fraction. So there's our 1/2. Yeah, and this calculator is nice. You can just really type in the answer just like it's written. So we'll get another fraction. Okay, there's our negative 2/3. Okay, we'll times that by y1 at 5. You don't need a times signal, or times sign, multiplication symbol. You just do that, y1 of 5 minus, so we found that f of 5 was 5, and then times that by the derivative of y1 at x equals 5. So math 8 d dx, and then we'll do alpha trace, which will get us the y1 when we hit enter, and then we'll do that at x equals 5, yeah. Okay, and then the bottom we'll just square, so we'll do parentheses, and then we'll do y1 of 5, so we'll go back to alpha trace, enter, open parentheses 5, close parentheses, and then we'll square that, and that's it. Whatever that is, that'll be our answer. Okay, and that's rounded to the nearest thousandth. Okay, so last one, they say for part C, find the value of x on the interval from -1 to 2 such that f prime of x equals h prime of x. Okay, so on this interval, f prime of x is linear on this interval. So let's look at it. On the interval from -1 to 2. Okay, so from -1 to 2, that's this line here. And so the derivative is constant, and it's always 2. So really, if we come down here, this f prime of x is always 2. So we really want to know where h prime of x equals 2. Okay, for us in the calculator, h prime of x is really y2. So for the calculator, we want to know where, so h prime of x is d dx of y2. And we want to know x equals x, and we want to know where that equals 2. Okay, so what we'll do, we can do this different ways. I'll bring the 2 over. We'll do d dx y2 at x equals x, and we'll subtract the 2, so it'll be minus 2. And we want to know where this derivative will equal 0. And so we'll really type this into one of the functions and graph this, and then calculate zeros. Okay, so let's do that. Bring this over here. Okay, so we'll go back to y equals. Okay, we don't want to graph y1, so we'll unhighlight, just hit enter when the cursor is over the equal sign, hit enter, and it'll unhighlight the equal sign. And so that means when you do that, that means the calculator won't include these functions. Since the equal signs aren't highlighted, it won't include these functions in graphs or in tables. Okay, so we'll make a new function for the derivative, and we want, remember this is y2 is h of x, so we want the derivative h of x, so derivative y2, and then we'll do it x equals x, since that's like the derivative of x, h prime of x, and then we'll subtract 2 so that we can calculate zeros. Okay, so we want to know where that y3 equals 0. Okay, so first let's go to the window and change it to according to the interval, because they're talking about the interval from -1 to 2. So let's change that for our, anytime they give you an x interval and you're doing something with the graph, pretty much always change the window, according to that interval. Make the x min and max the endpoints of the interval. Okay, and then the fact that we're just trying to find where the function equals 0, we want to know when y equals 0. So just make sure that the x min and x max contain 0. So we'll go from -2 to 2, or -1 to 1, -5 to 5, something like that. Just really any interval that contains 0. Okay, now we'll go second trace, which is calc, and do number 2 for zeros. So this is the 0 that we're looking for. So left bound, go left of that. Right bound, go right of that, hit enter, and then hit enter one more time, and that's the answer there. And you can see that's the x value, and you can see this -5 e to the -11, that's really 0. This is -5 times 10 to the -11th, which is some really small, close to 0 number that happens to be negative. But the calculator is not perfect, so this really is y equals 0. So that's the answer that we're looking for right there. Let's write that down. Okay, let's see. What was the question again? Okay, find the value of x. Okay, so at x equals 0.622. Prime of 6.622 equals h prime of 0.622. Okay, you don't have to write that, but just to see clearly what this answer is. Okay, and that's it for this one. Whoops. Get this all in view.